Hi, I'm Marc Marone, presenting this paper on behalf of my co-authors Orion Weller and Nathaniel Weir. We are PhD students at Johns Hopkins University, and we were advised by Don Laurie, Daniel Kasabi, and Benjamin Van Dermy. Consider an interaction with a language model, like the example shown here. Even when referencing sources, this system still gives some brittle and confusing answers. Language models have seen lots of data, some of it factual and some of it not. We know they can give us correct information, but sometimes they generate fake or even just uninformative answers. LLMs trained on the internet have seen lots of sites and information. So is there a way to make these LLMs use some of the better or more trusted sources? In this paper, we draw on the journalistic device of according to sources, and find you can simply ask LLMs to ground their responses against parts of their training data. We know that language models can memorize information. This can be harmful, for example, if it memorizes PII, or it can run counter to generalization and result in brittle systems that simply memorize answers. However, we hope to leverage memorization of trusted knowledge sources. It turns out that for an instruction-tuned LLM, you can simply ask it to answer a question using information found in its training data. In this case, we're using Wikipedia. We picked Wikipedia since it's a trusted source of knowledge that's often explicitly included in LLM pre-training data. When directly asked, a language model might not use all of the information from its pre-training data. But we find that some prompts cause the model to use more information from sources. We call these according to prompts. You can see here that applying a grounding prompt, according to Wikipedia, causes the model to emit more information that comes from pre-training documents. The highlighted purple text occurs in both the LLM response and documents from the pre-training corpus. Now you might be wondering, how did we measure those quotes? For that, we use a metric called QUIP, quoted information precision. For now, you can think of QUIP as measuring something like a blue score against all of Wikipedia or some other reference corpus. So in our work, we find that there exists a family of prompts that cause LLMs to quote more from certain sources, and we design a metric to measure this with an efficient implementation. We validate these findings on a large set of models using open domain question answering datasets in several domains: Wikipedia, medicine, and law. Now, you may wonder, why isn't this a retrieval augmentation paper? We think it is scientifically interesting to probe just the parametric knowledge in these models, the knowledge that's baked in from the pre-training process. It turns out that some information just needs to be unlocked. Let's start with our metric for grounding. Grounding can be a very broad term, but we're going to use a narrow definition that makes measurement tractable. This is quoting. We will use quoting and grounding interchangeably. Quoting is certainly not the only form of grounding, but we think it's a good target to measure. To measure quoting, we design a metric we call QUIP, quoted information precision. QUIP takes two arguments. Y is some input text, and C is a reference corpus. For example, let's let C be Wikipedia. QUIP is going to measure Y's membership in C. You can think of this like typical blue, but with multiple references, all the documents in Wikipedia. Similar metrics have been used as a proxy for memorization. For a Y that contains lots of factual information, we expect the score to be large. For a Y that does not contain many facts, like the second one given here, we expect the score to be smaller. Concretely, we define QUIP as the number of n-grams from Y that are members of the corpus divided by the total number of n-grams in Y. Note the indicator function that checks corpus membership. This indicator function needs to be efficient, so we use a specialized data structure called a Bloom filter. Why? A typical n-gram metric package, like SacreBlue, uses sets and dictionaries to keep track of n-grams. In Python, these data structures can consume a huge amount of memory. We instead use efficient data structures, borrowing this particular implementation from our prior work on dataset documentation. Note the memory consumption for 100 million n-grams here. It takes a lot of memory to store n-grams in a typical Python data structure. But by using a Bloom filter, we can do this much more easily. By our estimate, if we had naively scaled an n-gram metric to all of Wikipedia, it would have taken about 1.5 terabytes of RAM. Now, it's natural to wonder if an n-gram metric like this can really capture grounding. We build on a history of similar metrics like rouge and blue, but we also conduct a small human study to validate our metric. We bin 200 generations, in this case, results on the natural questions dataset by their QUIP-Score. We note how much of an answer appears to be a quote, ranging from none to all, and whether the answer appears to be a hallucination. As you can see, a higher QUIP-Score is associated with more quotes and less hallucination. Now we'll discuss how we got models to quote. We sourced a list of possible prompts from authors and performed initial experiments with ChatGPT. For example, according to Wikipedia, based on evidence from Wikipedia, go to Wikipedia and find some direct quotes, and so on. We also looked for anti-grounding prompts. These are ones that might cause QUIP to go down. Respond using information from Reddit, or respond without using any information from Wikipedia in your response. We evaluate ChatGPT on 4 question-answering datasets. We measure QUIP with respect to Wikipedia, and we also report task-specific accuracy measurements. We found that a variety of prompts asking LLMs to quote sources could increase QUIP compared to the null prompt baseline, which is just a typical question-answering instruction. The task-specific metrics vary, but for some prompts we see an increase in QUIP and similar or sometimes improved task performance. And for the anti-grounding prompts, we find they decrease QUIP-Score. Now, it's important to note that we weren't trying to find or optimize for the absolute best prompt performance. That would be brittle and model-specific. The most interesting part is that these prompts exist at all. You can get LLMs to recall more from their training data by simply asking. Now, what about other models? Using one of the prompts with strong performance, we conduct further experiments on a variety of other models. These range from small open source models to large API access models. We can see that QUIP generally improves for all of these models. Check out our paper for some further evaluation details like prompt setups. Now, what impacts this? Diving into some deeper analysis, we find that larger models are better at quoting. So here we see as the size of the OpenAI model increases, so does QUIP and the gap between grounding prompts and the null prompt. This is kind of intuitive, as larger models may have more capacity for memorization. It also makes sense when considering instruction performance. Large models might just be better at acting on the instructions in our prompts. To investigate a little further, we analyze the effect of instructions by comparing quoting performance of non-instruct-tune T5 to instruct-tune FLAN T5. Note that QUIP is higher, and the gap between grounded and ungrounded performance also grows for the instruct-tuned version. Since we are interested in increasing quoting from pre-training data, we also check whether entity popularity impacts our results. We find models quote more when it's a popular topic. Now, you may also be wondering if this holds outside of Wikipedia and our QA datasets. We know that Wikipedia is a broad knowledge source that is often explicitly added to LLM pre-training datasets, but what about some other datasets? We try according to PubMed and according to the US tax code. Both of these work. QUIP here is measured against other grounding corpora. One consists of the PubMed articles, and the other is built on the US tax code in 2022. Now let's look at some examples. In this example, ChatGPT gives an answer with more details. The highlighted text is from Wikipedia and contributed to QUIP-Score. In this next example, a smaller model, GPT-J Instruct, makes some mistakes. With the grounding prompt, the model includes more information from Wikipedia, which contributes to QUIP, but this information is not helpful and doesn't answer the question correctly. In conclusion, we find that LLMs can quote from their pre-training data. You just need to ask. We find a family of prompts for this behavior and define a metric. We also study variables that impact this behavior. Now, there are many further extensions to this work, For example, our metric considers only exact match quotations and thus might miss other instances of grounding. We also note that for some API models, we don't know which versions of Wikipedia are present in their training set. This could complicate future analysis. For more details, please see our paper. Thanks.